This is a new chapter, which is chapter 10 of class 10 NCERT, which is called circles. So we will delve into some concepts of in circle, and then we will also try to deal with all the questions which are present in NCERT chapter 10. So this is going to be very interesting chapter. So let us first look at the basics. So here you can see I have made a circle. This is a circle, and this is a straight line which I have drawn here for the circle. So basically, what I have done here, let us name this as maybe P, Q. This is a line, but you can see that it's cutting circle at 2 points. Obviously, it will cut circle at 2 points. So if a line is cutting a circle at 2 points, then that is called secant or intersecting line. Intersecting line. And when there is a line in such a way that it do not cuts the circle but just touches the circle. So in a way we can say that if this line PQ is such that it's it's just touching the circle. Let me make it a little bit more. Yeah, now it is touching the circle. So you can see that instead of, let us call this point A and B, where it actually cuts the circle, and then uh, when it just touches the circle, these point A and B, they just coincide at one point. Means there are no point A and B, there is just point, either we can say A or whatsoever. So if we draw the same line but it touches the circle, then it's called tangent line. So this line is a tangent line, and this line is secant line. So we have seen the two concepts, tangent line and secant line. There are many interesting properties of these two lines, which we will try to explore together. For example, the tangent to a circle is a special case of the secant when the two end points of its corresponding chord coincide. So this is what we are looking here. So here, this is a usual secant, and tangent is a special case of secant where point A and point B coincide and they just become one, and then they are just touching the circle. Let us go forward. Another very interesting point or the concept related to tangent is this one. Let us first make a tangent. This is a kind of theorem which we will try to see. Let me just make it a little bit better so that it actually looks like a tangent. Now it's almost a tangent. Okay, so what we have done here, we have made a tangent line, let's say PQ, And let us say here is the center of the circle. For example, let us call it O. So the theorem is that the tangent at any point of a circle is perpendicular to the radius through the point of contact. So what is point of contact here? Point of contact is this one, and this is the center of the circle. So if we draw a line, or which is a radius by definition, it will always be 90 degree. And wherever you make a tangent, doesn't matter. So even if the tangent is here, if you will draw a line from the center to the point of contact, which again will be radius, that will also be at 90 degree. So it will always be perpendicular. That is theorem, which is very, very important theorem. Let us also name it, for example, point T, and here maybe C. So here what we are saying, that PQ, line PQ is perpendicular to OT. Is that clear? This is PQ and this is OT, which is a radius. So now we have seen a very, very important theorem. Let us go a little bit further and try to solve a few questions. There is one exercise which is exercise 10.1 in the NCERT book. By the way, you can always freely download NCERT book for class 10 and go to this chapter 10 of circles, and then you can find these exercises. It's freely downloadable. The first question for exercise 10.1, question number 1, how many tangents can a circle have? Let us consider a little bit how many tangents a circle can have. You can pause the video and think about it, discuss with your friends, and try to come up with an answer. Okay, so now I will give the answer. Actually, a circle can have infinite number of tangents. So the answer is infinite. How? We can very well see from here, because any circle has infinite number of points. So when a circle has infinite number of points, then it can have infinite number of tangents also. Okay, so for example, here we can see on the circle there could be infinite number of points. So through all those infinite number of points, a line could be drawn which is a tangent. For example, here this is one point, one of all the infinite points, which could be a tangent. So infinite number of tangents. Let us go to question number 2. Question number 2 is it's a kind of fill in the blanks. Let us take the first question. A tangent to a circle intersects it in how many points? A tangent to a circle intersects, obviously it just intersects at one point. If it intersects at 2 points, then it will be a secant, not tangent. Next, number 2, a line intersecting a circle in 2 points is called a, we already have seen it. This is a circle and this is a line. So line intersecting a circle in 2 points. So this line is intersecting at 2 points. It's called secant. It's not called tangent, it's called secant. Let us go to question number 3. A circle can have how many parallel tangents at the most? That's also, let us have a look on that also. Let's make a circle here. And now, how many parallel tangents can a circle have? So just by little thought, you can very well see that as we have infinite number of tangents which we can have in a circle, so the pair of tangents which are infinite will the pair of tangents will also be infinite, means there could be as many as we want, because for each and every tangent, for example, this is a tangent, so there will be a corresponding tangent here which will be parallel, so there will be infinite number of parallel tangents, and then one parallel tangent will be this one. So let me just make it tangent. It has actually become secant. Yeah. So these two are again parallel tangents. Okay. So a circle can have infinite number of parallel tangents. Next question is, the common point of a tangent to a circle and the circle is called point of contact. We can also see here. So for example, if this is a tangent, so what is the common point of the tangent and the circle? So this is a tangent and this is a circle, and only one point is common and it's here. So that is called point of contact, obviously. Point of contact. And for any tangent, there will only be one point of contact. Now let us come to question number 3, which is a kind of numerical example. Let me just read out the question and then we will try to solve it. I will just read out the question and try to make a diagram that I will make in blue, and then whatever I do after reading the question and making a diagram, I will do in red, so that you know what is answer and what is a part of question. So let us start. First of all, let me just draw a circle because I know it will be a circle. A tangent PQ at a point P of a circle of radius 5. Okay, so basically this is center of the circle, and let this be radius, which is 5, which happen to be 5 centimeter. And the point tangent P. So the tangent is P and Q. So let us name it. This is the okay. And then there is, it mentions that the center is O. So I'm again reading the question. A tangent PQ at a point P of a circle of radius 5. Basically, the P is actually here. P is here because maybe P is the point of contact. And then Q is some point which is outside. So P is the point of contact and Q is another point on that straight line or tangent. Okay. And the center is O. So that's okay. Let us just go further. Meets a line through the center O at a point Q so that OQ is 12 centimeter. Okay, so it is telling that if we start from the center of the circle, starting from point O and make a straight line till point Q, the length of that straight line is 12 centimeter. Okay, so let us just write down here. OP is obviously 5 centimeter because it is radius, and OQ is 12 centimeter. Then it's asking what will be the length of PQ. So what will be the length of PQ? Now I will switch to red color. So up to this point I read the question and made a diagram. Based on that question, I have also written what kind of inputs are available. For example, 5 centimeter and 12 centimeter. And then we need to find out PQ. Okay, so let us see how to find out. First of all, it's very obvious, and we also read one property or maybe the theorem of the tangent to the circle, that it's always 90 degree. If we draw a line from the center of the circle to the point of contact to the tangent, it's always 90 degree. So basically we have to apply that theorem here. This will also be 90 degree, isn't it? Because it's the same situation. And if this is 90 degree, then it's a right angle triangle. Triangle OPQ is a right angle triangle, and we can apply Pythagoras theorem. So according to Pythagoras theorem, OP squared, one side squared, plus second side squared, PQ squared, will be equal to the hypotenuse, which is OQ. And now it should be very obvious. Let us put what is available. OP is nothing but 5. So 5 centimeter squared plus PQ, we don't know. We need to find out. So let us write PQ only. And OQ is hypotenuse, which is 12 squared. So just do some, so 5 squared is 25. So let us bring it here. So 144 minus 25 is how much? Okay, let us try to find out. I think it is 119. We can just delete this one. So it's 119, but that is PQ squared. So the PQ will be square root of 119 centimeter.